I don't know why most of my videos start with a view into the sky. 240 amps outside today, sweaty hot, and I'm back in the garage testing the new JK-BMS. Yeah, and well, there is a bit of a situation. Guys, first of all, welcome back to the Off-Grid Garage here in sunny, hot Australia. It is sunny hot, 38 degrees again. I'm maximizing the time I spent in the pool. The battery was already full at about 10 o'clock and sits on 36 degrees, so it's not too bad actually, considering we're measuring 41 degrees on the outside of the garage. See, this is where the ruby tag is on the outside, and I've put this insulation panel underneath, and there's an air gap as well, but there's still heat radiating from the metal roof here. So it shows a higher temperature than we actually have. So last night I have started testing the parallel function of the JK-BMS, and yep, red t-shirt. So as you remember, initially I had the JK-BMS 200 amps here connected to our Frankenstein battery, and this BMS always had trouble to connect to my computer because I had to use the inverter RS485 port to connect to the computer software, while usually you connect to the internal RS485 ports, which are for the internal communication, the paralleling of BMSes. But this connection never worked with this BMS. And JK suggested that we may have a faulty BMS here. This is one of the first ones they have built, so they sent me one over fairly early to start testing it. And I could not establish a connection between this 200 amp BMS and the 100 amp BMS in the JK battery. There was no communication, nothing showed up on the PC software, no parallel batteries, nothing, zero. That's where I took the 200 amp prototype BMS out and put another 100 amp BMS onto the Frankenstein battery. Yeah, connected all the cables, everything was fine. Communication started up. And I have asked JK what the process is now of paralleling these BMSs with batteries. And they said, well, it's very easy, and sent me this list. Yeah, this is just a list how to set the dip switches on the BMSs, but we know this already, how to set them. I was more after a general procedure, a manual how-to guide. So I don't know if the master BMS needs to be on address 0 and the first BMS on address number 1, or if the first one needs to be on 1 and the second be on 2. I don't know, we have to try it out. So this is our master battery here at the moment. We have both RS485 ports connected, one of them to the computer, the other one to the second battery. And this one shows address 1. Well, here in the JK battery, with the second JK-BMS, I have set address number 2 and plugged in the LAN cable to the communication port. Yeah, you would say, well, Andy, this is not number 2, this is number 4. Yeah, it's 1, 2, 4, 8. But for some reason, there seems to be a small incompatibility between the JK-BMS communication board and the PACE BMS communication board, because for some reason this one is totally mirrored. So it starts actually from the other side, 1, 2, 4 and 8. If I set the first one, I'm getting address number 8. And if I set the one on the right, I'm getting address number 1. So this one is definitely number 2, and the master is now set to number 1. You can see it here in the Bluetooth app, number 1 and number 2. And this one is supposedly our master BMS. Alright, let's connect to our device. Here we go. This is number 1, and it shows us battery number 1. Yeah, that is 93%. I think this is the one I just connected, and it should still show 40 ampere hours. Yes, it does. While the other one in the JK battery shows 100 ampere hours. So, and now with the newest JK-BMS monitoring software 2.40, link is down below, we also have the parallel tab here, which we can click and then select which battery we want to connect to. So we are, why does it say device is disconnected? We are number 1, number 2, 3, 4, 5, 6, 7, number 0. No, it doesn't show us any. We need to disconnect and then reconnect again. No, it goes back to real time and only shows number 1, device ID number 1. Okay, let's change this one to device ID number 2. Connect. And this should show, yeah, 35% exactly. It's not calibrated to the JK battery. And we should see, oh, I was expecting we are seeing the 100 ampere hour here, but it's still showing the 40 ampere hours. Okay, parallel. Nothing. There's nothing connecting. Damn it. So this is definitely the JK battery it is showing now, because this is connected for 3 days now. This is when I did the video. But I cannot see the master. Parallel. Nothing. Let's log in with a password. Try again. Device 1, device 2, nothing. Okay, change the Frankenstein BMS to address 0. All dip switches down. And change the JK-BMS in the JK battery to address 1. So we just do a quick rescan here. Yeah, we can see one is 0 and the other one is 1. So that is perfectly showing. So the address is correctly set. Real time. Disconnect. Go to... See, I cannot choose device ID 0 here anyway. Connect. And this is again the JK-BMS, 3 days, 3 hours. Definitely not the Frankenstein one. So this is the slave battery we are connecting to. Parallel. There's nothing working here. Nothing. Ah, hang on. Here we go. Slave battery, address 1. And this is the new master 14 minutes. Yeah, that's the brand new BMS we just put in. Ah, now it's working. So it gives us all the details for master and slave. So that means the master BMS needs to be address 0 and the first slave battery needs to be address number 1. And then you continue. It's good to know. Yeah, it definitely shows 40 ampere hours for the master BMS. Let me quickly connect to the slave battery via Bluetooth. This one sits on 40 as well. I thought we have changed it to 100. Okay, it looks like I'm not able to connect to the slave battery via the computer software once they are connected in parallel. Settings, it only shows me the 40 ampere hours of the master battery. Parallel. Here we go. It takes a while to connect. Master battery 16 minutes and device 1 is our slave battery, 3 days. So this sits on 100 ampere hour now and the master sits on 100 ampere hour as well. What the heck is going on? Come on, JK, not again, not again. Surely you have tested this, right? You tested this, didn't you? Okay, this is now the master BMS I'm connected to. I'm changing here the capacity to 280 ampere hours. Click OK. This is our Frankenstein battery. Yeah. And immediately we could see the state of charge dropping to 37% as well. This is 100. Both showing 100 ampere hours. Why is that? That makes no sense. One is 100, the other one is 280. Okay, anyway, let's plug in our blue cable, which is our CAN connection to the Servo GX. And we plug this into the CAN port, which is this one. There we go. Okay, let's have a look in the remote console, go into our settings. And we have the smart BMS here showing us 37%. We go into that. There's no charge going in or out of the battery now. The you have seen the pull fan system is not existing anymore at the moment. We will have a different solution soon. Details. So cool. It shows us 2 batteries online. It shows us the lowest voltage and the highest voltage, but we don't know which battery they are in. The same for the temperatures. It doesn't give us any indication which battery it actually is. So cell number 8 is the lowest, but which battery? We don't know. So there's some information missing. Number of batteries, blocking charge, discharge, 2 and 2, because the function is turned off in both BMSes, that's fine. And we have an installed capacity of 380 ampere hours, which is 280 for the Frankenstein battery plus the 100 ampere hour for the Jacob battery. So that is perfect. This is the first BMS which does it actually correctly, so we can mix and match different capacities with this BMS here. And obviously it shows us a available capacity of 139 ampere hours. So 139 ampere hours, this is the available capacity of each battery as a sum. Alright, let's go back in the software and connect. So it says 100 ampere hours here, parallel. See, it takes a while to connect. Not doing anything. And then it connects. See? It does it, but it takes a while. Maybe I just wasn't patient enough. Why is the master BMS showing me 100 ampere hours now? This is the Frankenstein battery with 280. And this is the slave, the Jackie, which has 100 exactly here. So this gives us a remaining capacity of 36 ampere hours. While this one gives us a remaining capacity of 37 ampere hours. And this in total makes 139. JK, please, please. Let's do the maths for them. 36% out of 100 gives us 36 ampere hours, right? 37% out of 280, not 100, 280, which we have set in the BMS. 280 divided by 100 times 37 is 103. So 103 plus 36 is 139. And this is exactly what the Victron system shows us. So it submits the data correctly, but it shows it incorrectly in the computer software. JK. Master BMS sits on 280 ampere hours. See, 280 ampere hours. So if you go back to the slave, sits on 100 ampere hours. So it does the calculation correctly, it submits the data correctly to the Victron system or to your inverter, but it shows it incorrectly here in the PC software. Maybe we shouldn't use this stupid PC software anymore because it's just not working. We use it for upgrading to a new firmware and that's it. Forget about the PC software. It is stupid. Totally fucking stupid. Mann, ey, das kann doch nicht sein. Wie schwer ist es denn, so eine Software zu machen? Nee, da wirst du zum Hirsch. That is a German saying, which means becoming a deer. Something like this. Alright, let's go back and go into parameters. Charge voltage limit, 67 volts. Now I'm really becoming a deer. Let's go back in the master BMS. Master BMS, right? We haven't set lithium iron phosphate in this master. That must be 4.2 times 16. Yeah, that is 67.2 volts actually. Okay, lithium iron phosphate. And we want to charge to 3.45 volts, right? Oh, nee. Okay, this goes to 55.2 volts now. So if I now go into the slave battery and set something different for the RCV, for the requested charge voltage, which is your absorption or bulk voltage. Let's see if this one changes actually. It shouldn't change. It shouldn't. Okay, password, settings. See, this sits on 4.19 anyway. Why is that? Why is it sitting on 4. And set this one to 3.4 only, right? 3.399. It needs to be lower than the RCV for some reason. For whatever reason, they have put in this logic, which is not logic. Okay, it doesn't change this at all. It doesn't change this. It would only charge to 54.4. Well, it wants to charge to 54.4, but because all batteries are in parallel and the master tells your charger to charge to 55.2, it will actually charge to 55.2. So it's not using the charging settings or algorithm in the slave battery. It uses the master battery for that. And this is perfect. This is how it's supposed to be. Still, if you put in like 3.5 volt as your over voltage protection in the slave battery, then the BMS will turn off the slave battery if you reach this voltage. So the protection parameters are still valid for each battery individually, but the charging parameters and the charging logic is only coming from the master battery. Thank you, JK, for not making me a deer. Okay, let's check out the CCL and DCL functions as well. So let's log back into our master BMS. Why has the master BMS again 40 ampere hours sitting here? 280, okay. Why has it fall back to 40? So we just check the continued charge current 100, discharge current 100 amps. Go into controls and turn on charge, turn on discharge. And we should see the 95 amps showing for both, because it keeps 5% as a margin. Okay, let's go into the slave battery. What? This one sits on 40 ampere hours again as well. 100 ampere hour. Oh, really, guys? Okay, continue charge current 100, discharge current 100. Go into here, turn on charge, and see what the CCL does. It should go to 190. It doesn't? Go on. Ah, here it comes. Okay, perfect. 100 amps for each of the BMSs makes 200, and they take 5% away. Just so if you have any spikes in your current, it doesn't trigger the protection. And we turn on discharge as well, which should show 190 as well then. Great. Okay, so this all works. Perfect. Okay, so what happens if one of your cells hits an over voltage protection and the BMS turns off this one battery? So we turn off our slave battery here, discharge off, because one cell is low, it goes back to 95. And in this case, it would only keep discharging the master battery because the slave has got an under voltage protection and the BMS has turned off the MOSFET. So if we do the other way around, we are fully charging the battery now and one of your cells hits over voltage protection for whatever reason, it shouldn't. This is a JK-BMS with a 2 amp balancer. The master would now tell the inverter, hey, throttle down charging to 95 amps only, because one of my banks is not playing the game anymore, has completely disconnected from our parallel setup. And then the inverter charges the remaining batteries with 95 amps only. And there would be nothing going into this battery bank. I'm just having a look at the aggregated information sent to the Victron system. It shows us a state of charge of 73% now. Let's go back into our single JK-BMSs. The master shows us remaining capacity 73%. The slave shows us a remaining capacity of 72%. Okay. 3.15. Okay, I changed the cell voltage, the RCV, to 3.15. This should actually now reset to 100%. So there's one battery on 100% and the master is on 73%. Oh, there's something not working. Definitely not working. It obviously only takes the remaining battery capacity in percentage and submits this to the Victron system. And this is only the capacity, the state of charge of the master BMS, not an average of all your parallel batteries. Let's check again the slave. Yeah, this one sits on 100%. Okay, that is a bit, what do you think? Is this important? Because usually when you have batteries in parallel, they all have the same state of charge, more or less. There could be 1, 2, 3% difference or something, but usually they are all in the same boat, right? So therefore, is it enough if the master BMS reports its own state of charge to your inverter instead of taking into account all the other state of charges of all the other batteries? Or does it need to read all this data and do an average state of charge and reports this to your inverter, which could be slightly different to what the master actually is? How precise do you want to go? I think it should do it. Well, from a pure logical perspective, it should actually take the average and report this one to your inverter, not only what the master battery state of charge is. So I think this is a bit of a bug. Okay, I'll report this back to JK and see what they are saying. Again, usually they are all very close together, so it doesn't make too much difference, but this is not correct. So now a bit of an experiment. I have connected the JK battery with the JK-BMS now to our bus system. And I've done the same here with the Frankenstein battery and the second JK-BMS, which is our master. Yeah, master, slave. So the JK battery should be at around 50-60% state of charge, while the Frankenstein battery is around 100% state of charge. So there will be current flowing from this battery into the JK battery. And we may see the current limiter triggering in the JK-BMS in the JK battery. Yeah, all of these BMSs have a 10 amp current limiter function. So if we go over 100 amps, which we have set in the settings, normally it would trigger an overcurrent protection and would turn off your MOSFETs. Well, with this current limiter function, it keeps the MOSFETs on and just limits the current down to 10 amps per BMS. Well, what we can do is we can actually go into this slave battery and we can set the continuous charge limit to like 30 amps, right? So if we hit these 30 amps, the BMS usually would turn off, but now with the current limiter, it will just limit the current going into the BMS to 10 amps. So let's see if we can see 10 amps now. Okay, let's go into the master BMS. Master BMS, turn on discharge. 3 amps only, 3 amps! This is 60% state of charge and 100% state of charge. Frankenstein battery is discharging with 2 amps going into the slave battery. And we should see roughly 2 amps here as well, 1.7, 1.8 going into the battery. So let's see how this looks like in the Victron system or in your inverter. It shows 0 amps because we've got well, like half an amp going out of one battery and half an amp going into one battery. Negative 0.5, positive 0.5, max 0. So that means the aggregation of data is being submitted correctly to the Victron system or to your inverter. So I have now connected a load to our 2 batteries. And this is showing our master BMS with negative 5.3 amps. Let's see what the slave battery shows. Negative 2.6, which makes then negative 8.3 in your inverter. So it is actually adding these 2 currents together and show this correctly in the Victron system or in your inverter. So perfect. So, and in the next step, we want to test the resolution or sensitivity of the JK-BMS. We are starting with the 100 amp BMS here in the JK battery. I have already connected the power supply. And we are starting with 500 milliamps of charging current into the battery. Okay, let's turn this on. And you can see 0.2. Let's check on the current. Yeah, I can measure 0.5 amps here as well with my clamp meter. So I guess the power supply and my clamp meter are correct. And the JK is just not calibrated for these small currents. So we now have a charging current of 5 amps. The JK-BMS shows us 4.6. So we go into settings, verify the password and set this one to 5. Okay. Yeah, that doesn't make a difference here actually. Okay, so I'm not 100% sure how precise the JK measures the current. Go to 10 amps. It shows us 9.5. If I type in 10, hit OK, go back. Okay, we now have 10.0 amps. Okay, this is as precise as we can get. Okay, let's go down to 0.5 amps. BMS shows us 0.2. 400 milliamps now into the battery, and the BMS shows us 0. So this is at 0.4 of an amp. I measure again with the clamp meter. Yeah, 420 milliamps, and 400 the power supply shows, but the JK, oh, there's a frog, but the JK shows 0 to 0.2. If I go even to 0.3 amps now, power supply matches my clamp meter, the BMS shows 0. So I guess 0.3 of an amp is the sensitivity of this BMS. It's 100 amp. Okay, let's do the same for the 200 amp BMS and see if there's a difference. Okay, we are now connected to the 200 amp JK-BMS, and here we start with half an amp and see what the BMS says. Need to turn on the charge MOSFET. Okay, let's do the same here. Let's see if we can calibrate the BMS to 1 amp. It shows 0.4, 1 amp, sending failure. Nice. Okay, let's try the same with 10 amps. 10 amps. Okay, that shows exactly 10 amps, 10.4, 10 amps. Yep, that should do. Okay, let's go down to 0.5 and it shows 0. Okay, resolution obviously is higher in the 200 amp BMS. 0.6, 0.7, 0.8. Okay, 0.8 of an amp. And then it shows 0.4 of an amp in the BMS. 0.7 shows 0. So that means everything under 0.7 amps which you charge or discharge your battery, it won't be detected by the BMS. Okay, so this is pretty much in line with the Pace BMS, which has 0.5 of an amp resolution, and the Seplos BMS, which has 0.8 amp resolution. Alright my friends, I think so far the video from today testing the new JK inverter BMSs in parallel, and so far everything seems to work. We are getting the right data. CVL, CCL and DCL are correctly displayed and aggregated between the parallel batteries. The summary of current between your master and the slave battery is being submitted correctly, and so far everything seems to work just fine. I cannot find any problems at the moment. Well, the only problem I found making me almost a deer is the PC software. But they already told me it is not finalized, it doesn't seem to work correctly with parallel batteries. So I would recommend only using the PC software to update your BMS to the newest firmware, and then use the mobile app on your phone to set all the parameters. Unfortunately, if you have a whole stack of batteries with a JK-BMS inside, you have to set them up individually, one after another. There's no export and import function in the app where you can set one battery, export the functions into a file, and then load this file onto all your other BMSs again. So they all have the same settings eventually. This needs to be done manually at the moment. I'll definitely put this on the list of requested features for a future update. Yeah, unfortunately one of my BMSs seems to be faulty for some reason. It didn't update correctly. Stopped at 3% and then went to 4%, and yeah, it is not responding to the computer software anymore. It is not responding to the mobile app anymore. It doesn't beep when I turn it on and off. So for some reason it seems to be pricked. I think I have read some comments about this as well, that some of you guys have experienced the same. So please leave your comments down below. Share your experience with upgrading these devices. Has it worked, or have you experienced the same and one of your BMSs is now pricked? I'm trying to find a solution for that and see what JK wants to do with this BMS. Alright guys, as always, thank you so much for watching. Thanks for all your great support here. Thanks for all your very generous donations recently. Buying me a cold drink down here in sunny hot Australia. You can see me shining all the time when I do videos in the garage now, right? We are well over 35 degrees here in the garage, so it's not very pleasant. But what can you do? The show must go on, right? And until the next video guys, when we do something... Until then guys, you stay charged, stay safe, and thanks again for watching. See you then, bye bye. Oh, look at this mush of cables here. I hate it. I hate it. This situation will all change, and we will get a proper test set up where all the cables are... This is not acceptable.